I hope I'm audible and you are seeing my screen. Okay, today we are going to discuss more on the clustering. In the morning, for about next 45 minutes, I'll be teaching you how to do the clustering. When the data is being given, it is unsupervised algorithm. Yesterday, we discussed about classification algorithm, right? So you all learn how to work with the decision tree. Today, I will brief about one of the clustering algorithm, which is very famous clustering algorithm. I'll teach clustering and I'll explain you about k-means algorithm. Using k-means, how you can cluster these data points. I have one superb example which I'm going to show you. There will be a small work in the morning. Okay, let me start talking about the positive point and story. There was a guru. He was very famous. That famous guru, if you go and study with that Guruji, then you will be the best. Okay, so people will always love to go and study under that Guruji. And that Guruji lives in Himalaya. So there are two guys from southern India. They started traveling for a while. They reached Himalaya, right? And they wanted to get the training from him. When they spoke to Guruji, Guruji said, sorry folks, I can't take you, and my seats are full. I only teach 20-25 people per batch. But they just say, sorry sir, please help us. We came all the way and we wanted you to consider us. Then okay, he asked to wait. Then after the session got over, he came and then gave something. He grabbed something from his hut, right? So he grabbed something from both hands and then gave it to one person, another to another person. Go and come back with whatever you got. That is a test. So if you fail in this test, you have to go. You should not compel me. If you pass, I will take either one of you or both of you. That was the thing. Okay, 1 month got over. He says 1 month's time. So they were there till the time. So first one person came. He was coming with like a dull face and saying, "What, Guruji? What assignment you have given? I thought you are a Appatakar Guruji. You are a very famous Guruji. You give some excellent assignment and things like that. You have given some mokka seed, karab seed, mokka vedaya kurtute. You have given some seeds and then wanted us to test this. Anyhow." With all hard work and all those things, here there is no rain, there is no water, and you should have given that seeds in a nice pack. You just like that gave. On the way itself, I dropped some of the seeds. Everything got and then there are some seeds are boiled seeds, some seeds are karab, I mean bad seeds, and nothing grown from that. And I have to go struggle to get water, and there are some birds problem. There are so many problems with that. I got some flower like that. He has shown 2 sunflower, samandipu, whatever. He gave that to the Guruji. Then Guruji said, let's wait for the other person. After 1 hour, the third person came. He was coming with 2 big basket A, basket B. Also on the head, he has on something on his head, right? Guruji was astonished to see him. Then the Guruji helped, and the other boy also helped to put it down. Then Guruji asked, what happened? Guruji, I loved your assignment. I started taking your the seeds which you have given carefully, and I have taken my towel and then I took all those seeds carefully, did not miss any one seed. Then here the data mining concepts are going to come also. I tell this story for the data mining class. So I cluster the seeds. I classify the seeds. First, I cluster the seeds. Which seeds are good seeds? Which seeds are boiled seeds? Which seeds are bad seeds? It doesn't grow. So I have clustered it first and took the cluster. In that cluster, I classified what type of seeds they are. Are they flower seeds or vegetable seeds, or what type of seeds? I kind of classified all those seeds, and then trying to find. Now you have to apply the regression, right? I applied a matching technique and applied some mining and looking at the pattern, what seed, what soil I should use. Okay, I kind of mapped Okay, so for this type of seed, this type of soil is needed. I put some, I have segregated according to the type of soil required. Then I started, planting those seeds, putting the seeds. Of course, there was no water. For first couple of days, I have to run for about few kilometers to grab water. Then nearby that plant, I started put a little hut, started digging the small well. So after 3-4 days, I started getting my own water from the well, and then I started putting it. Every day I started seeing the growth of the plants. I was thanking the plant. I was wishing the good thing. I was thanking God. I was thanking you, and then celebrating every day. And this is the success, right? So this is what he told. That's a result of this. Okay, so from this story, what is the positive point you can infer? Do you like to be like a second guy? Guru obviously has taken the second person, right? What was the difference between the first and second? Anybody? Excellent, Valalmadi madam. Thank you, Mr. Ranganath. I asked you a small question. What was the characteristics which differentiate between the first and second? Can you just throw some light on it? Regulation, intelligence. Computer sense is common sense. Ranga's favorite quote. It's okay. Yeah, intelligent, of course. That's exactly I'm looking for, Dr. Vallistri. Good morning and good day. Positive attitude. Excellent. That's exact precise answer. The person with a positive attitude, right? So, starting from the way you start interacting, how he was proceeding, right? Once you are positive, you have a positive attitude, right? You can just continue with the things correctly. I always like Mahatriya. Mahatriya is one of the famous guy. He has given one nice quote, right? If you believe yourself, no one in the world can stop your growth, including God. If you don't believe yourself, no one in the world can help you, including God. So first, you believe yourself, have a positive attitude. Whatever you do, go with the love, go with a positive attitude. Like you yourself have to appreciate you. You don't look for appreciation from others. First, you appreciate yourself. You encourage yourself. You motivate yourself. Self-motivation is the greatest, successful principle. With that, I will start the clustering. You seeing my PPT? What do you mean by clustering? Clustering is nothing but, ma'am, you're able to hear and see the presentation?
Yes, yes.
Thanks, Ranga. So clustering is also called as grouping. Yesterday, we just discussed about partitioning and binning. Do you remember we talked about partitioning rule and then binning rules? So, but now we are putting the cluster. Cluster is an unsupervised algorithm, and it is trying to identify which are all related, which are all similar, which are all dissimilar. How do you find a similarity? How do you find dissimilarity from yesterday's session? Can you tell me? Suppose I know the coordinates here. I know the coordinates here. Suppose this is clustered nicely. Assuming that this is not clustered, it is like distributed across. What is the technique you can use to find the similarity between the object?
How can you cluster yesterday's classes?
Yeah, we covered some technique yesterday morning. I explained some similarity metric, this similarity metric. Then there was a method we covered. Ranga also talked about one famous Indian scientist.
They are saying color and distance.
Okay, no, that's not. I'm talking about. Like say, assuming that you have this. Can go with the pointer. Okay, suppose I know the value here. I know the value here. Okay, so how do I find the similarity and dissimilarity between these clusters?
Points which are close can be a cluster. Proximity measure based on distance.
Excellent. That's where I'm coming. Okay, what type of methods you can use to find the distance? You learned about Euclidean distance.
Three different distance. Name them. Euclidean, Manhattan, and then
Min.
speak about India.
All right.
Father. I forgot.
Okay, no problem.
Yogendra madam said Mahanubolus. Yes.
Excellent. Thank you. So we wanted to minimize the intra-cluster distance. Suppose I formed a cluster. Suppose cluster of product prices. Okay, 50, 60, 70. And if I form a cluster in a group, in that group, the distance between the cluster point, the data point, should be minimized. In data structures and algorithms, we use a word called coupling and cohesion. We wanted to have loosely coupling between the cluster, tight cohesion. It has to be cohesive, right? So one of the important goal of the clustering is you use any algorithm, we need to minimize the intra-cluster distance. What should I do with respect to distance between this cluster and this cluster? Should I minimize or maximize? Any answers? Suppose this is cluster A and cluster B, cluster C. What should I do? Should I have these clusters should be close or should be distance should be higher?
Maximize.
Excellent. Excellent. Inter-cluster distances are maximized. We would like to create a separate cluster and there should be some reasonable distance between each cluster, right? So please take down these important rules, okay? And see, a good clustering method will produce high quality clusters with the high intra-class similarity, high intra-class similarity, low inter-class similarity. So the quality of clustering results depend on both similarity measures used by the method, what similarity measure you are using, and based on the implementation. So it can be anything. Use any method, any algorithm, but the quality is decided based on the similarity measure. Also, another level of quality is just this, because we are talking about data mining, we are talking about deep learning. We wanted to find some interesting pattern. See, quality of software testing. I used to teach software testing. One of the important guideline for a software tester is not only finding the known bugs. The software tester should find unknown bugs also. He should find something which they did. I mean, the developer did not think about. Even customer did not think about. That is a quality, right? So you need to even find out some hidden patterns, right? So there are many clustering types are there. So I am going to only explain only one cluster today, and then maybe me and Ranga were discussing. We will frame the advanced session such a way that we can have a advanced data mining wherein yesterday there are like we only talked about one classification algorithm, right? So we just discuss about decision tree. There are Bayesian classifier algorithm is there, and there is a priori algorithm is there, and then there are even in the decision tree itself there are some random forest algorithm is there, right? There are many advanced level of algorithms are there for the classification. Even clustering. Today I'm going to only cover one of the popular methods called k-means algorithm, right? And maybe tomorrow or end of the day, if I have a time, I will also talk about KNN. The KNN will be useful for both classification and clustering. I will explain you, in the evening when there is a chance. And but there are a lot of algorithms in the clustering, right? So DB scan algorithm and batch algorithm, right? And then a lot of hierarchical clustering algorithm. There are like a density-based cluster, proximity-based cluster. A lot of algorithms are there, so we will that could comes under the advanced session. Okay, so if you see this, we will partition the cluster based on hierarchy. We can build a hierarchical tree, start with one first, and then keep on building the hierarchy. Right? Suppose if I wanted to form a hierarchical cluster of your session now, I can take starting with the Sudha ma'am, and then who is next to Sudha madam. So I will form a cluster like that. I'll keep on building the cluster and build the hierarchy, right? Or I can use this partition clustering wherein divide the cluster into non-overlapping subset. We don't want to have a overlapping, right? So we wanted to have a non-overlapping subsets, right? So we can use this partitioning clustering method that is called k-means. I'm going to teach you one k-means algorithm. So there is a PAM method, Clara method. There are new, the algorithms. Okay, so I will give you a quiz for you. Please find out abbreviation of PAM, abbreviation of Clara. What is PAM? What is Clara? Right? They basically follow the standard k-means algorithm, and then they will try to improve that. Right? So basically, in the hierarchical cluster, what we normally do is we call that as a tendogram. So, for example, there are a lot of data is there. We first start with the any number, anything. So, and then from 1, which is near, from 1, what is a number which is near? 3 is near. So, we form a first cluster. So, this is the first cluster, and then we just find out the distance between this point and the other point. So, this is the first tendogram. T cluster has been formed. Then we look at it between 2 and 5. There is a shorter distance, so we form another cluster between 2 and 5. Then then we looked at 2 and 5 and 4. We basically, if we look at 2 and 5, there's a lot of distance with 6. So what we do is we just take this 2 and 5 and then add with the 4. So we form another cluster. Then looking at this cluster and this cluster. So these two clusters can be little near. So we group this together, and then with that we create the hierarchy. So that is basically called hierarchical clustering, right? So it is called tendogram. So basically it can be very much useful for if you are following a structured approach, you can use this hierarchical clustering, right? And there is one of the famous algorithm called Adoramatv clustering algorithm. What we do is we are first finding the proximity matrix, the distance matrix. Let each data point be a cluster. We start with every point being a cluster, and then we repeat, merge the two closest cluster, update the proximity matrix, and we just until only a single cluster. Finally, there will be one big cluster. That cluster have so many subcluster. See, we start with the cluster. Okay, like these many points are there. What we do first start with P1, okay, P1 and P2, P3 and P4, and then like so on, right? We'll create a cluster, and then we keep on finding the proximity matrix. So we'll find minimum, maximum, and the group average in that cluster, distance between the centroid. So there is one mean here, there is one mean here. Yeah, centroid is nothing but the mean value. So what is that, distance between this mean and that mean, right? So that is how they will do, like finding the minimum. So we wanted to have a minimum, okay, so and then maximum distance between these points, and then the group average should be consistent, and then distance between centroid. So what we normally do, if you look at this example, yesterday we have explained about the equivalent distance. Suppose these points are given, x coordinate, y coordinate. P1 is 0.40, 0.53. See this? P1 is 0.40 and then 0.53. Okay, so this is this one, 0.40, 0.53. This is P1, and then this is P2. So we have this many points. What is the best way to cluster this? First, what we are trying to do is we are going to build what is this matrix? Do you remember this matrix yesterday? Did you remember seeing it? Any answers you are seeing, Ranga?
Square matrix.
Oh, okay.
Yogendra madam says dissimilarity.
Excellent. That's a correct word, right? Correct answer. So it is a dissimilarity matrix, right?
Not confusion, Rajesh. This is not confusion matrix, Rajesh.
Yeah. Confusion matrix is about the positives and negatives. True
positive, true negative has to be there, Rajesh. Sir.
Yeah. See, as you see, the distance between P1 and P1 is 0. P2, P2. Remember, we fill all these diagonal values are all going to be empty, 0. And now we are trying to find the distance between P1 and P2. Anybody knows how we got this 0.24? What did we do? Between P1 and P2, how did you get this 0.24? Any answer? So we take...
Krishnakant says Euclidean distance.
Correct. So we take this x1 minus x2, right? Y1 minus Y2, right? So we do the square and then square root. Remember the Euclidean distance formula? Then you will get this 0.24. So you have to do this, and then you're trying to start forming the cluster. So like I introduced yesterday, like there is a lazy versus eager learner, right? So lazy learning algorithm simply stores the training data without doing any further munching on the data till it get the next set as it, right? But in the nearest neighbor is also like that, right? So eager learning, like addition tree, Naves Bayesian, artificial neural network, right? So I will cover this little later. Let me explain you the outliers quickly. Then I will explain you one problem for k-means algorithm, right? This is very important for you to know about outliers, because one of the way to find the outlier is you can form cluster. You can form cluster, and then anything can not belongs to a cluster, you can make it as outlier. See, these are all kind of nearest thing, looking at these things which is outlier, right? So a data object that deviates significantly from the normal object as if generated by a different mechanism. Outliers are different from the noise data. It is not an error. Noise is a random error or variance. Outliers are interesting. Sometimes maybe outliers give some different kind of information to the scientist or to the analyst. So like credit card fraud detection, telecom, everywhere we have univariate outlier, right? So why we get this outlier? Maybe a data entry error, maybe a measurement error, maybe experimental error, maybe intentionally they're trying to put this error, sampling error, maybe not an error, novelties in the data, how that the data is there, right? And so that's why we use this anomaly detection technique to find the anomaly, right? So this is an interesting thing for research. Ma'am already told me some of them are doing the research. See, this is the best research area for all of you to work on. Anomaly detection. There are so many anomaly detection techniques are there. Okay, so you can apply any statistical method, information theory, spectral theory, data mining algorithm, machine learning algorithm, deep learning algorithm, right? So you can apply that to any domain. Intrusion detection in the networking or fraud detection, image detection, medical informatics, bioinformatics, whatever you want. You can choose the domain, you can choose the research area, take any one of that, right? And then you got to define the characteristics of the problem. You have to define the nature of data, sampling of the data, and then you label the data, define the anomaly, and then find the output, right? So this is one, this is a survey paper by our Indian author, Varun Chandola, Aridham, University of Minnesota. This is a US university. This is in ACM computing surveys. So people who are going to pursue their PhD or, yet to plan, they can think of the anomaly detection as one of the biggest area in the, this will be from the clustering side. Okay, now take the paper and pen. We are going to do one k-mean algorithm. Okay, why k-mean algorithm? It is very simple algorithm, and it will help you to, group, cluster the data so quickly. Suppose I have 60 students in the class. This is from my class notes. One of my students has taken this so neatly from my explanation. So I talked to her in the morning. I asked her to send the image, so she has sent that image to me. So like suppose I have 60 students, I can divide into like 4 clusters, G1, G2, G3, G4, and I need to define how I wanted to form this G1. And Amazon is using this clustering algorithm to categorize the products. Different products are divided into different categories, like electronic products, different brand products are in a different bucket. So there are 2 types of cluster as we see: central cluster or centroid cluster and hierarchical cluster, right? Central cluster, we take the data and then trying to find the mean value, and we are trying to find the check whether it is closer or not. I'm going to show you the algorithm. In the hierarchical cluster, we basically start with one and then trying to form a cluster, trying to merge the cluster, and then finally bridge one bigger cluster, like a tree-like structure. Okay, now we'll go on to the take a paper and pen. So let me tell you the algorithm first. What we do in the algorithm, we first take the mean value. Okay, first you need to assign how many clusters you want. How many clusters, k clusters you want. Okay, so I wanted to, with the given data, do I need to form, Ranga, this image is clear, Ranga and Sudha madam?
Yes, yes.
Okay. So you have to say, do I need to, what type of clusters, how many clusters I want to form? 2 clusters, 3 clusters. So you have to decide the K value. There are some algorithms available for even designing the K. What is the best way to decide the K? So first what we are going to do is we take the initial mean value without calculating it, because we don't know. This can be from the input data, or you can randomly choose. This can be a random mean value which can be selected from these values, or you can even take any of the values, or you can say, for example, here I can say 6 or 7, right? I can say 15 or 16, random guess, you can have it, but you should not give 100 or 200. Something within this range, like a lower to higher value, you can decide, two values, right? So the goal is, now we are going to apply 2 means cluster. Okay, we wanted to, with this data, please take a note of these data points, all of you. Did you make a note of these points? 2, 3, 4, 10, 11, 12, 20, 25, 30. Let me know once you are done. We done that?
Yeah, they're saying yes.
Excellent. So now we are going to make 2 clusters, 2 groups from this given data. These 2 can be anything. 2 product orders, 3. Maybe this is like purchase orders from the participant. I mean the shopping people who are going for a shopping. Okay, between 9 to 12, they purchase some products, right? So 2 products, 3 products, 4 products. Maybe you can have it. This is all electronic product. This is the electronic product. So they wanted to categorize, the cluster, how best we can cluster these, orders, right? Purchase orders, right? So what we are doing first is, initially, we don't have any mean value. We don't know. So we are going to consider any random value. Because we are talking about 2 cluster, I'm going to start with, for this problem, I'm starting with the mean value as 4, and then I'm choosing mean value as 12. You can choose anything, even you can choose 25, you can choose 4, right? Or you can choose 3 and all. You can choose anything, even not in this set also. You can say 6, you can say 22, no problem, right? But you need to start with some random values initially. Random means you can choose anything, right? So for this problem, for an easier calculation, I'm using this M1 equal to 4, M2 equal to 12. Is that clear? Step 1 is clear. So we are taking the mean value. Suppose if the K is 3, then you need to have 3 means. K is 4, then you have to have 4 means. Suppose there's a data set is so high, then we need to have 4 clusters. Then you need to have 4 mean value, 4 guesses. Are you clear with the step 1?
They are saying yes.
Good. Next, step 2 is, now we are going to use this value. This is our initial guess mean value. From there, what is that we are doing in the clustering? Finding the similarity. What is the distance? Which is closer, which is not closer. Take this 4 first, and then check with the 2, check with the 3, check with the 4. Okay. So, okay. And then when you check with this 4 with the 10, okay, the distance is 6. 4 with 11, distance is higher. 4 with the 12, distance is higher, 8. Whereas if you look at 12 and 10, the distance is what? Distance is only 2. Whereas you go with the 4 and 10, distance is 6. So then obviously we put anything like related to this mean, we'll put it into a different cluster. And then for this, 4, we are always putting into these 2, 3, 4 are the nearest, the proximity distance is shorter. You cannot, find this 4, and basically how we do is 4 to 10 is 6. 12 to 10 is 2. So we go with this. 12 to 11 is 1. 4 to 11 is 7. So we ignore this. So we don't put it here, we put it here. That's the way you form the cluster. So we first cluster, did you all do the first cluster? 2, 3, 4. Are you clear with the first step? So now we use this value, looked at everything, finding which is nearer, which is closer proximity. We group them like a 2, 3, 4. And then K2 with a 12, we got 6 numbers. So initially we formed 2 clusters. The first cluster is little small, second cluster is little big. Is that clear?
They are saying yes.
Excellent. Now the initial guess is over. We started with our first step. What is the algorithm says? find the nearest number to the mean and put it in the cluster. So now we are going to find the mean value because this value is changed now. This cluster is changed now. You cannot go any more guess. So now you need to find the mean value. You all know how to find the mean value. 2 plus 3 plus 4 divided by 3, 9 by 3, which is 3. Now we got the new mean value of 3. And with this value, if you add all those things divided by 6 numbers, you get 18. This is your step 2. Are you clear with the step 2? Now we find the mean of this. Now what do we have to do? Again, start iteration. Oh, from this mean value, I am going to find out the data set. Is it near or not? Now see the interesting thing. Between 3 and 10, what is the distance? Between 3 and 10, what is the distance?
You're saying 7.
Excellent. What about 18 and 10?
8.
So which one you will put? 7 you put it in, the 10 you put it here in the new cluster 2 or put it in the cluster 1?
One madam is saying 2, others are saying 1.
Yeah. So because we wanted to see, even it is 0.5, we wanted to consider that, right? So because here, if you look at this 3 and 2 distance is near, and 3 and 10 is 7, which is minimal. So we put it here, right? And then we got this rectification cluster. So 11, 12, 20, 25, 30. Now we got new values. Now this cluster has one more extra point. Here is one is reduced. Again, you calculate the mean value. You should ask now, when did you stop? When the mean doesn't change. No more iteration. No more. You cannot do anything anymore. I grouped it. I grouped all these people like this. That's it. And so, if when I'm, after I do this, for example, I wanted to put all the 50 age group one side, 50 to 52, and then 60 to 70. If I did it correctly, even if you shuffle, it's not going to make any difference, right? So the mean value, if it doesn't change, you stop the algorithm. So now what we are doing, summing all these 4 value divided by.
Revati madam is asking a question. Until to get constant mean, question mark.
Yes, correct. Until get the constant mean, correct. So now what we are going to do is we got 4.75 in the step 3, and then we got 19.6. You can round it because it is 0.6. You can round it to 20. Here 4.75, you can round it to 5. See, this is a different value now. It is not really in the cluster value. Again, I'm telling you, this guess can be any guess, not necessarily from this data set. Okay. So now we are trying to look at this 5. Okay. And then we are looking at which are all the value closer to 5. 2 is closer, 3 is closer, 4 is closer, 10 is closer. Now we are looking at 5 to 11. 5 to 11 is 6. Whereas 20 to 11 is 9. So we put that 11 here. And then again, we are looking at 5 to 12, which is 7, whereas 20 to 12 is 8. So we put that here. And then now we are looking at 20 to 20, 20 to 25. We can put this here because 20 to 12 is 8. 20 to 2 is 18. No way we can put it in this cluster. Now we got 20, 25, 30 in the second cluster. And K1 is 2, 3, 4, 10, 11, 12. Right. So this is, now when you do a mean value, you get M1 equal to 7. M2 equal to 25, right? So now you are trying to look at this 7 to 2, 7 to 3, 7 to 4, 7 to 10, 7 to 11, 7 to 12, okay? And then we look at 7 to 20, which is, 13, whereas 25 to 20 is only 5. And then 7 to 25 is 18, and then 25 to 25 is 0, and 7 to 30 is, so that's it. Again, if you look at it, you get the same value. If you do the mean is same, and mean is same. So this is end of the cluster. So that is what it is saying. Repeat the steps until we get the same mean.
Madam, there's one question.
Yeah.
Madam, is it called as ranking or grading, sir?
It is not ranking, it's not grading, it is basically
classifying
and clustering, harmonizing the data. And you can actually, you can give a rank if you want. Okay, if you wanted to have like a higher class or lower class, you decide your mean value. Based on that, you can cluster. Average, you can decide. Oh, if the students are in this average, I wanted to give them the rank of A. Yeah, you can do that.
Can I answer that, doctor?
Yes, please go ahead.
Once, see, in the real life situation, when you get a clustering problem, when you cluster a given set of customers or a given set of universities, the next thing is about labeling. That's where your success is. So if you are able to rank those clusters, that's where you label. I'll give you a very good example of, you are going to cluster all the universities. So once you cluster the universities, the next thing you will do, madam, is you will start ranking them as top universities, medium universities, low universities. Similarly with credit card customers, high profile customers, medium profile customers, low profile customers. Okay, so that can be considered as your ranking and grouping. So that is step 2, which you have to do on a live production environment. Thank you. Hope we answered your question, Revati ma'am.
All right. So let me show you one sample code of K-mean, how this K-mean works, right? So I'm going to share the code. First, I'll copy these things for you all. All of you take this. Now we are going to use this data. Now all of you are do it along with me. Yeah. Oh, is it all copied or not? Not sure.
Oh no, see, it gets cut. After figure, do the plot again. After figure, plot dot figure.
Yeah. After figure. Okay, fine. Okay, I have to copy these lines, right? PLT.
From scatter.
Yeah. Yeah, please give it a try.
Don't copy this.
Only the line of plot, scatter.
Just highlight that, doctor. PLT.s. Just highlight it.
Yeah.
On the top. Tell them not to copy that.
Which one? This one. Yeah. Don't copy this point. PLT SC. Don't copy it. So you have to copy up to this FLG. Don't copy that PLT.SC. So you can copy from this points. Okay, I'll just show from the. Yeah, take it from import pandas up to this figure, and then done.
Yeah, they're already done. Yeah.
Excellent. Now I'm going to take the. We are going to start assigning the values. Okay, so and we are going to initialize the centroid. Initial centroid we are going to initialize. Okay, then we are going to calculate the. So you all seen this graph of this. Now we are going to cluster this effectively, right? So it will take some time to show. So let me see. I'll put it in a notepad and then. Ranga, would you like to show that simple one rather than me? Probably you can show that if you want.
That is KNN. It's okay.
Oh, yeah. Okay, fine. So, what should I do? Could I send a mail quickly? Okay. What? Actually, this is in one. This is one of the code.
Dog, just you run it and show it to them. You send a mail. I will after the break. I'll make them do it.
Excellent. That's good. Thanks, Ranga. This is done now. We are giving the coloring. Okay. So earlier we have a different thing. Now we are kind of creating a distance. Based on that, we initialize the centroid. We find the centroid. Okay. And then we are trying to find out that's basically we are using the distance calculation, right? And what did we do in the K-mean algorithm? We are trying to find out the difference between the value and the centroid. Did we do that in our PPT, right? What did we do? We got the mean value 4 or 5. Then we are looking at the the centroid, that mean, and then distance, right? So that's what we are trying to do here, and then get it. And then the next step would be, I'll send this a link in the chat. You can just follow this. This is one. I have one very complex code. I got this one, which is very interesting and easy for you all. Part is, you can use this update. Now there is more, and this is how the clustering is going to work in an unsupervised manner. Now you are trying to add additional points. Now the existing cluster, I'm adding additional points. How this is going to work? Already being formed. Now we are adding additional data point. That's how the unsupervised works, because we did not give any label. In a classification, we have given the label. Here there is no unlabeled data set. Now we got new data, new things being formed. So it is trying to find some 2 points here, 2 points here. Now we added additional data. We updated the cluster. Okay. Then the very next step will be, we wanted to repeat the assignment, and then finally, they are looking at it, how this is train the model, and then repeat that. Then you will see that, now the cluster values are going to be changed. So this is all going to be changed now, if you look at it, right? So this code I've already shared with you. See, this is being changed. You look at it, right? So it has changed, and then it formed the cluster. And here there is one little point. So this is all like separate, and this is separate, this is separate. So this is how the new points are being understood and then being added, and then added into the cluster. This is how the clustering algorithm works. Any question before I hand over the session to Mr. Ranga? So there is a link has been shared with you all. So I will again join probably around 11:30, 11:40, and I'll be with you guys in the afternoon. Okay, so the afternoon session is good. Thank you. Please listen to what Mr. Ranga is going to cover, which is going to be very, very important, text mining and NLP. So understand it. It is going to be, you'll be filled with a lot of fun and exciting exercises. And I'll also try to come and then show you one problem, how to calculate the TF, IDF, and few things, how depending on how it goes, right? So with that, I will end my talk, and Ranga, you can take over. I'll stop my presenting, and we'll share this presentation, whatever we have explained. I will send you this presentation through Sudha.
Just keep talking. I'll join in a minute. Keep talking.
Yeah, no problem.
The other question is there. How to determine the efficiency of clustering?
Madam, what is the question?
How to determine the efficiency of clustering?
Yeah, I told you, basically the quality, that is the first thing I told you. There are many parameters are there. I'll show you the clustering. We wanted to find out the square, that the square error. Yesterday we talked about it, right? What is that error? MSE. What does that mean, square error? Remember? So we find out the cluster is efficient based on mean square error and based on the intra and inter cluster similarity. Okay, and we will find. I'll show you cluster evaluation. Where is it? Oh.
Yeah, thanks, Doc. I'm back.
Yeah, one question I'm just trying to address on the clustering. Yeah. I hope this is it. Yeah. So you can evaluate the cluster based on mean square error, and then there are a lot of performance metrics are all there. I'll just show you quickly. Yeah. Evaluating k-means cluster, right? For each point, the error is the distance to the nearest cluster. So we all know, like last class, Mr. Ranga covered you. So to get the SSC, we square these errors and sum them, right? So given two cluster, we can choose the one with the smallest error.
Yeah,
So
you have to use the RMSE value.
am I sharing my presentation or not?
No, no.
Oh my goodness.
You can use the MSC, RMSE, or
Yeah.
mean
There's
percentage.
lot of metrics are there. One of the important metrics is this. Now you are seeing my slides.
Not yet.
Is it? Yes or no?
No.
Really?
No, sir, you are not presenting.
I am presented already. I am presenting it. I don't know, somehow it's
No,
not. Somebody,
present now is open.
I don't know. There is a problem here. Okay. So basically, I will tell you the points. I will send this. All I'm saying is, if the good cluster means we want to reduce the SSC, right? So how you reduce SSC to increase the K value, right? I will share this in the chat. I don't know whether I can.
You know what,
Yeah.
Doctor? If time permits,
Yeah.
I will show them from KNN how the errors are calculated and how every.
Yeah. Excellent.
So this way they'll have a.
So now I tried only 1 second. I don't know whether it is getting it or not. Somebody present. That's right. Is it now you're seeing?
No.
Still no?
Still, yeah, no.
No, sir. Actually, no one is presenting.
I don't know what's happening. I tried to present it. Anyway, please make a note. If you want to evaluate the cluster, okay, so you have to use that SSC, right? So we choose the cluster.
Just watch the
Smallest
chat.
error.
I just sent it. So this is something like an example where if the K is 1, the test error, train error, you see this? This is how we measure the accuracy. You keep changing the K value, the error, we spoke about the best fit, right? Under training, overfitting, underfitting. It has to be like here. This seems to be a good fit where the errors are close by. 77, 78. This is how you measure. Root mean square error, MSC, mean square error, or root mean square error. We can also use mean absolute percentage error. Okay, madam?
Yes, sir. Yes,
Okay.
sir.
And the person who asked the question.
She
Menega, madam.
told already. Thank you. She told already.
Okay, I think doctor is trying to reconnect. So while we is trying to reconnect, let's start the session. Good morning, all. Let me just share my screen. We're going to be talking a little bit about what we missed out yesterday on the CNN, RNN, and then we will move on to the data clustering. So let me just turn off the video. Okay, so hope all of you are doing good and ready for the interesting ride ahead as usual. So basically, let me start off with two small little stories. One is about don't judge. Generally we are very good at judging, right? So we generally look at something and we judge right away. So this is about, they usually say don't judge the book by its cover. So that's in relation to that. A few of you might know this. So a lot of you might not know this. And so I thought it could be a refresher. So there is this scene you can imagine. There's a 25-year-old boy who's traveling in train along with this.
The presentation not available.
I'm not showing the presentation, madam.
Okay.
I'm just showing the screen. Actually, madam, please mute yourself. Yeah, thank you. So they are traveling on the train, and there are other people obviously traveling the train as well. So this, whenever the train started moving, and then it's slowly starting to go on, and this is about 24-year-old guy. He's starting like, "Oh, daddy, look at the tree. Wow, look at the sky, and it's raining. Wow, it's raining." It's making all, and people coming, "Oh, look at this. This is a beautiful baby." So he's saying a lot of one after the other. And there is a newly married couple and like young girls sitting in the train, and they're kind of looking weird. What's wrong with this kid? He's 25 years old. He's getting excited looking at the tree. He's getting excited. The train is going fast. Daddy, the train is going in the front and the trees are going in the back. Oh my God, fantastic, Daddy. I love this. So this guy keeps on saying this. Initially, they were quiet. And then after a while, they really got frustrated and went to the father and said, is your son mad? Is he kind of, he's got any kind of issues with brain? What is this? He's 25 years old and he's getting all excited about seeing trees and little babies. When the train goes in the front, the trees going in the back. He's getting overexcited. Wow, what happened? Is there something wrong with him? The dad keeps quiet. Can anyone take a guess? Why did the boy react like that? Exactly. The father slowly tells, you know what? We just got him operated. He has been blind for 25 years. This is the first time he got operated and he's able to see things and he's seeing it for the first time. Obviously, wouldn't you be excited? So we do that mistake all the time in our lives. We straight away judge. We are good at judging others, aren't we? When it comes to us, we are always right. When it comes to others, they're always wrong. We're always good at judging people. Immediately look off it, we'll say, okay, this guy is not smart. This student, no good. Okay, so let's not judge the book by its cover. Let's try to understand the situation and try to read into the people who we come in contact with. That can keep us energetic, that can keep us happy, that can keep us less stressed. Because the moment you start coming to conclusions, your stress levels goes up because you are setting an expectation for yourself. The lesser the expectation you have in your life, the lesser frustration you're going to have, the lesser disappointments you're going to have. So that being said, and one little thing about teachers coming from the very infamous Vivekananda. Vivekananda is sitting with his mother trying to peel the apple and cut the apple. So he's telling his mother, "Mom, I think I'm ready to go start teaching people. I think I have acquired enough knowledge and I'm ready to go and deliver the speeches." The mother says, "Is it? Okay." So she just quietly says, Vivekananda is using a knife. He's cutting an apple, you can imagine, or doing something. So she says, "Can you hand me over the knife?" Vivekananda handed over the knife to his mother. The way he handed the knife over, his mother said, "Son, you are ready to become a teacher now. I am proud of you. You can go ahead. You have passed the test. Can you tell me why did his mother say that? How did Vivekananda hand the knife to his mother? Yes, he held the sharper side towards him and he gave the handle exactly on the side and he gave the handle to the mother. So that's how we teachers are. We have to be like that. We have to always take the sharp end and give the best to the students. Okay, so with that, let's get into business now. Hope you guys kind of jacked up with the stories. Let's move on to business now. So, Sudha madam, if there are any questions, you can let me know. I'll be
Yes, sir.
concentrating on that. Yeah, since Venkat is not
Sure.
around.
Sure.
So yesterday we started off with deep neural networks. What are the things that comes to your mind? Can you shoot me on the chat? I'm watching you all. When it comes to deep neural networks, what are all the important things that you remember? Can you just tell me with a quick top of the mind recall? Let's go. Start. Multi-layer. Okay. Let's start from single layer, Professor. Single layer perceptron, input layer. Okay. Keep going. Keep going. Number of hidden layers. Very good. Weights. Input bias activation. Excellent. Very good. Very good. How does the layer gets activated? Prior to activation, what is that layer called? Within the neuron, there are two activation function. Before the, what activates the function? Net function. No, madam. Threshold. Correct. How does the threshold arrive? Something called as a summation function. Very good, doctor. Summation or integration function. Okay. So that is what. Okay. So if I have two neurons as my input, how many, so let's say I have two variables as input, how many neurons will be in the input layer? I have two inputs. Why three, madam? I said only two inputs. I said only two inputs. Bias, very good. Remember that, do not forget. Two inputs with one bias. How many weights will be there? Three weights will be there. Bias will also have weights. What is the default value of the bias? 1. Okay. So, what do you mean if I tell you it is a fully connected network or a dense network? What do I mean if I say it is a fully connected network or a dense network? Okay, feed-forward network, okay. No, sir, not bidirectional. When I say it's a dense network, I'll give you a clue. You have a multi-layered perceptron. You can take a look at this. Look at this and answer. This is called a dense network. Why? I explained it. So whatever is in your screen is called as a dense network. Why? These are all very important things. That's why I'm
All
doing it.
neurons are connected to each other. Mesh connection in dense.
What is
Connected
it?
to next layer. Overfitting.
Overfitting. Saranya madam, why are you bringing overfitting here? Each neuron, that's correct. All the neurons, you see this? It's connected to this, to this, to this. Okay, each neuron is connected to every other neuron. That is when it is called as a dense network or fully connected network. Okay, very good. So, I also told you there is something called as a class. If I have a 10 class problem, how many output neurons will be there in my output layer? I have a 10 class problem. How many output? 10 neurons. Beautiful, excellent. What are all the activation functions you remember? The names of some activation functions that you can recall. ReLU, beautiful. Sigmoid, softmax. Can anyone tell me the difference between ReLU, sigmoid, tanh, and softmax? Softmax is different. ReLU is nonlinear. Okay. How about softmax? What is the beauty of softmax? Softmax is multi-class. How does it do it? How does softmax give you multi-class, Krishnakant? Answer is correct. Yeah, that's fine. How does softmax do when we have, yeah, 1 second. The professor says, sir, when we have feedback or error feedback, then what? Okay, professor, because feed forward, all the networks are feed forward. When you propagate the error back, What is that? I told you it is called. What network or what algorithm will you use? We even gave you a program with that name. That was the name of the program itself. The Python code. Exactly, back propagation. Yes, back propagation. So feed all the networks are feed forward and back propagated. Okay, sir, that's what it is. Krishnakant, that's fine. Anybody can tell me how the softmax works? Probability. Does it ring a bell? So it creates a probability for different. Here, see, this is a softmax. It creates a probability to say whether it is a dog, bird, cat, depending on the probability values you can assign. Okay, when you are back propagating, there is something called as eta. I said eta. What is that called? What is the name of eta? Learning rate. Excellent. What is the learning rate we suggested for beginners? 0.1. Nice, nice, nice. Do you remember the learning rate that we used in the program Python code? Did anyone notice that? .5. Okay. So does anyone remember the formula? New learning rate is equal to old learning rate plus. Does anyone recollect the formula? Anybody? New learning rate is equal to old learning rate plus eta into, what did we do there? What do we need to put there? Exactly. Fantastic. Error is actual minus predicted into the input. Fantastic. You guys remember everything. Nice, nice. Superb. So you guys are clear with the deep learning from the basic concepts, right? Excellent. So we are going to build on that. Nice. Glad to know that you guys are able to recollect. So this gives me a confidence that I can also teach. Thank you. Thank you for giving me the confidence. Okay. This is a multi-layered perceptron, which is called as a dense network. We get an input image. We will go through the input layers, the hidden layers, the softmax will find out.
One question is there from Jayapati and said, what about modular NN?
I'm sorry, madam. Modular NN. Modular neural networks, is it?
Modular.
Modular neural networks. I'll let you know, sir. I'll check and let you know. I haven't come across that. Modular neural networks. Maybe they're talking it in modules. I don't know. I'll check and get back to you, Jayapati. So these are all the probabilities on the dense network. So now we are giving a prelude on why we got ImageNet and why we got the CNN. CNN stands for Convolutional Neural Networks. There is something called as ImageNet, which is available. You can go to this www.image-net.org and they have 22,000 categories and 14 million images which have been recognized and hand annotated. What do I mean by hand annotated is they will take this is an animal, this is a bird, fish, mammal. They'll find it hand annotated and they will update that database. Okay, so there are at least 1 million of images with bounding boxes are also provided. Now, ImageNet started conducting competitions where you will be given a set of categories and you will have to identify the image using artificial intelligence. So they started a competition. This is called as, you can go on it and you will find ImageNet classification challenge is very famous. If you see this diagram, we use something called as feature engineering, remember? When in 2010 and 2011, when people were using the feature engineering logic and trying to classify, okay, and trying to classify, the error rate was almost 30%, 0.28, 0.26. All of a sudden, in 2012, the error rate in the competition dropped to literally half of what was there 2 years back. You see this, assume for argument's sake is 30% and this is 15%. So it's almost a 50% drop in error rate. They said, oh, wait a minute. What is going on? What did this guy who won the award or won the challenge use? That's when they came to know that he has used a mechanism or a neural network type which is called as convolutional neural network. So from there they kept on improving and see amazing results. From 2010 with 30% error, in 2017 they brought the error to 0.023. What do I mean by classification error, gentlemen, ladies? When I say 0.023 is a classification error, what is my accuracy? What is my accuracy on the classification challenge that this participant would have achieved? Or let's say
2.3%.
I'm sorry?
2.3%, high 0.7, 97.7.
Exactly, 97%. 97, no, it is not 97, it is 99. It is 0.03.
Yeah, Professor Jayapandian is telling 99.067.
Yes. Imagine the accuracy level. If you show an elephant 99.97%, it's going to say it's an elephant. Fantastic. That's how great this convolutional neural networks are. CNNs are very good if used on images and video. That's what they majorly use it for. So where do we see CNN? Sir, you're saying CNN. CNN, where is it used, sir? It can help you to classify. You see, it can say semantic segmentation, classification, localization. I can do object detection. Whether the person entering, see, if I have an attendance system, and the attendance system has to only allow humans inside. If a dog also comes inside, it can stop you. See, right now, the CNN is in use. BITS Pilani, I don't know about any of your organizations are using it. BITS Pilani is using artificial intelligence, CNN, OpenCV based mentoring system for proctoring the exams. Is anybody else using that? Has anybody proctored video proctored? Okay. So this proctoring works like that. We did online proctoring of exams. Myself and doctor also did it. For we also have it on this Sunday. We did it last Sunday. We did quite a few. Yeah, NPTEL does it, correct. So there they use this. If there is somebody in that room, immediately it will do this object detection and say there is another person in the room. Immediately it will give a red alert. Okay, so CNN is used there. Object detection, segmentation. I can segment. Okay, I can see where what is coming is a bus or a. This is being used heavily in the highways. They will find out how many vehicles are passing through the tolls. It's already been another speed at which it's passing through. A lot of it has been used. There is also another famous challenge called as Kaggle is another competition-oriented one. Any students or any research scholars, I would request you to look at all this Kaggle, ImageNet classification. These are all the challenges you should participate, or you should ask your students to participate. That's when you will grow your knowledge. So please make a note of all that. ImageNet challenge, Kaggle, CNN Kaggle whale identification challenge. So you can't go near a whale and identify the different types of whales. So they were able to use CNN and capture the pictures, and just with their fins, they were able to train the images and give whale IDs and come to a conclusion and come with a good results. This is one of them. Then we also use it for image captioning. So if I give this picture to the CNN, it will say this is a man wearing a straw hat. I'm just only identifying the straw hat. Okay, so it's used in image captioning. So it's done heavily. It is already done. If anybody of you has got your pictures uploaded in the Google Photos, you will be amazed. You just go in there and see, it already has got captions. Has anyone noticed that? Yes, Professor Vikas Dubey, good catch. CNN plus RNN is used. Excellent. Good, correct. Has anyone tried checking it in their Google Photos? Go there. It is already captioned. A lot of the pictures are captioned. Okay, little girl in a pink hat is blowing bubbles. Like Professor Dubey said, because Dubey said it is a combination of CNN and this is recurrent neural networks. He will tell you. It remembers the previous one. Straw hat. That's how it's giving you straw plus hat and an N. We will be showing you RNN. Good observation, Professor. Okay, now what we're going to be doing is we're going to be talking about what is convolution, why do we need convolution. So we saw this dense network with inputs here, right, for an image of a cat. So in general, the way for image classification, how it works is, if this is a, and I'm sure all of you know that we measure the photos in like 32 by 32, right? The pixels, 32 by 32 pixels. This is 32 by width and 32 by height. This is the pixel we measure. So if I'm going to give this input image as an input to this multi-layered perceptron, how many neurons should I have? If I'm giving a 32 by 32 image, how many neurons should I have in my input layer? Any clues? No. Wrong, Revati madam. I want to give a 32 by 32 image. Exactly. Yogendra madam. Exactly, Krishnakant. You need to give 32 multiplied by 32. Whatever the number is. I think it's 900. What is the number? Anybody does a quick math and tell me the number of neurons? Calculator. So 1124. So I need to give 1124 neurons. Okay, 1124 neurons, it's all right. Now imagine if I have to give a one, see, because 32 by 32 pictures will be like this. Okay, it will be all blurry. Imagine, see, and then I have to add 3 color channels to it if it's a color picture, or I will have to add 1 if it is a black and white picture. So the weights that I need to supply will become 3072 just for the first hidden layer. If I have a 1 megapixel image, I will have to feed a neuron to the tune of 10 to the power of 6. Oh my God, 10 to the power of 6 is 10 lakhs. 10 lakh neuron. The system will die. So they figured, that's why there are so much of errors when they use the normal methodology. So they figured, if you look at this cat picture, the cat is here, okay? The cat is here, and you see the areas where there are pixels which are of no use. I only need this part of the picture where there is a lot of high intensity pixels, right? All of you know pixels, right? Pixel, what is a pixel? What is a pixel? Because I need to ask that question.
Picture element.
Picture element.
RGB
Yes,
value.
picture element. Okay. So does anyone know the values the pixels can have? The numbers. What is the range? Excellent, Professor. 255, 0 to 255. Superb. What does 0 represent? 0 represents black. 255, obviously white. That's it. So it is in that range of 0 to 255. So that is the value that needs to be represented here. So let's say, looking at this, I'm saying, okay, why do I need to take all the pixels and unnecessarily feed my network and overfit the network? So I thought I will do a convolve future. I will explain, but I want to see from whatever you have learned and from whatever your existing knowledge, can you look at this particular picture, see that animation that's going on, right? Can you tell me what is happening? This is, I'm reducing this 5 by 5 image into a 3 by 3 image. What am I doing? Can anyone tell me what am I doing? Take a look at it. Let the animation play. Can you tell me what's happening? What it is doing?
Selecting the desired only.
I'll give you a
3
clue.
cross 3 convolution.
I'll give you a
3
clue.
cross 3 convolution.
Just watch the yellow squares. And the numbers in red. That's the clue. Just watch it.
Sir, answers are coming. 3 cross 3 convolution to get 1 pixel.
Okay, super. What this is doing is, we are applying a filter. You see this? 1, 0, 1. Okay, let me stop this. If I go here, it'll stop. Okay. You see this, it'll be a little small, but I will just try to make this a little bigger so that I can go back. I'll just change it so that all of you can see. You see this? Is it visible, madam? Nice and big.
Yes, sir. Visible.
So what it is doing is, this is called as a filter. You are taking a 3 by 3 filter and you are applying it on this area. So I multiply 1 into 1 plus 0 into 1, 0, 1 into 1. So 2. 0 into 0 is 0. 1 into 1 is 1. And then this is 0. Okay. So far I have got 3, right? Now I'm multiplying 1 with 0 is 0, 0 with 0 is 0, and then I'll multiply 1 with 1, I'm getting 4. So I convolved this 3 by 3. When I applied this on it, I got 4. Similarly, it's called a stride. I will move this 1 stride here. I'll come from here to, I'll come here. Then I'll move my stride here. I'm applying that. So when I do this multiplication, this 3 cells, this 3 by 3, I get a value of 4. For this 3 by 3, I'm getting a value of 3. For this 3 by 3, I'm getting a value of 4. Then I'm applying this filter. I'm coming 1 stride down. For this 3, I'm getting 2. For this 4, 3. Like that, I'm moving my filter. So if you just imagine the last one again.
Yogendra madam and Sridevi madam is asking to repeat it again.
Yes, what I'll do is I'll just show there and do a marking. It'll be easier.
Krishnakant also asked, can you please explain again which cells are getting multiplied?
Yes, I will stop here. Take a pen and paper, all of you. Just take a pen and paper for me, please. And I'll also now open up a notepad. Okay. So the filter we have is,
So,
just look at this filter.
Subhai is asking what is mask weights?
I'm sorry, madam.
What is mask weights?
Mask weights. Let's first finish this CNN and then I'll come to his question. Let's first understand the convolved future and then I'll come to his question. Here, what is here? I want you to look here. Let's take this one. I'll do one and then you will understand. Okay? Or we can even do this. It's already highlighted one. We'll see whether we'll get this value 4. Okay? Just look at here. So let's take 1 multiplied by 1 plus. We have 1 and 0, right? 1 multiplied by 0 plus 1 multiplied by 1. Okay? Plus. So just let's finish off one row so that we can add up. So we have 1 plus 0 plus 1, we have 2. Then again, let's come here.
Sorry sir to disturb you.
Yes.
So I was asking about this cross in the way it is written, no? Cross 1, cross 0. So these are the weights of the filter. So that simply I was asking. Thank you, sir.
Okay. Yeah, those are all called as weights, masks. Mask. Oh, you're asking about mask. Okay, okay. It is also called as a mask. Correct. It's called as a mask. It's called as a filter. I have it in the next slide. So I'll come back to you. Even if you have any other doubts, I'll clear it. So I'm just multiplying 1 with 0. 0 plus 1 into 1 plus 0 into 0. So how many do we have? 1. So far all of you are with me? You're able to follow? And I'm applying 1 multiplied by 1 plus 0 multiplied by 0 plus 0 multiplied by 1. So again I have 1. So the total I get 2 plus 1 plus 1, I'm getting 4. So that is the value that got convolved here and became 4. Similarly, how you do this is you apply, start from here. I'm not able to do this one. You clear? I'll go and draw there. Are all of you clear, madam? Just ask them. Are they clear how
Yes,
they
sir.
got this 4? This exactly applies
Yes,
to
all
all.
are telling yes.
Okay, super.
All are telling yes.
Okay, great. So here it's moving. It's got that. It's an animated feature. So see how it is moving. Just follow. This is called as a stride. See, it's moving one at a time. It's starting from here. Just all of you pay attention. It will start again. See, 1. See, it's just moving one column and then one row. See, second row. So this is called as stride. So it moves. So this is called as image mask or image filter, if that is what Professor Vikas Dubey was asking. It's also called as a mask. Okay. This convolution, when it creates this convolved feature, it is called as an activation map. So I apply a 32 by 32 by 3 image on with a 5 by 5 by 3 filter. See this 3. If it's a RGB, red, green, blue, it is 3. If it's black and white, it's 1. Okay. So it means I'm giving a image with a color filter. So this creates how many ever? If I create 3 filters, it will create 3 maps. If I create 5 filters, it will create 5 activation maps. So it will keep on convolving, it will keep on reducing that and keep picking up the main pixel image. See, this one, when you give the input data, there will be a lot of convolutional feature maps. That feature map will be put onto a pooling map. And that pool map again can be convolved. Then you get a linear classifier and get your categories. I'll explain what the pooling map is. It's nice and easy. So you get the input, You convolve the stage, detect transform non-linearity, pooling stage, normalize, and output the feature. Okay, so you can give a 160 by 160 into 3. So these are all the maps. You do a max pool or average pool, and then you will do a dense, something called as dropout. So dropout we won't be covering because it's an advanced concept. Dropout is a part of transformation or a tuning technique where we will stop. I'll quickly explain what the dropout is. Dropout is, let's say there are so many neurons. Let me go back. It's easy. Somebody's on unmute. Can I request them to mute? Thank you. There are a lot of neurons here, right? So what this dropout mechanism does is, assume there are 100 neurons here. Okay, these are 100 neurons here. What in the dropout mechanism we will do is, all of a sudden, we will make these neurons, you can imagine for now, like as if it is not working. I'll make these neurons to stop taking input and giving output, not do this job. So what happens? A good example is, your department has got, let's say, 10 people, right? All of a sudden, your dean comes to you and tells you, you know what, from tomorrow, there are only 5 people who are going to be working. 5 of them has been deputed somewhere, or they won't work. They have been fired because of COVID situation. This 10 of them were doing some work, right? They were doing some kind of a work. Now, the output cannot change. If they were in total, if they were handling 10 classes and 10 subjects, these 5 people have to handle the same 10 subjects. What happens? 2 things. One, the workload goes up. Let's say you are good at computer science, okay? They have also stopped the ECE stuff. They cut one of the ECE stuff, and they're also asking you to take a class in ECE. What do you have to do as professors? You will have to learn, right? Because you don't know ECE. You are a computer science staff. They're asking you to take ECE also because they fired one of the ECE staffs, and they are falling short of staffs. Maybe it's already happening with quite a few of you. You actually cross departments or take subjects that are not a part of your subject. That is exactly what happens. By force, what you are doing, this neuron, which was not learning what this neuron was doing, will be forced to learn 1, 2, 3, and a lot of other stuff. So that's how dropout was. Are you clear? Did I make you understand what the dropout is?
Yes, sir. All are telling multitasking, common sense,
Yes.
Changing with situation.
Exactly. So they are making, this is the agile methodology. The company, they'll say, this is exactly how it works in NASA. You should know everything. You should not show this is my area, I won't work. They took that and they applied here. So I think I'll just quickly give the convolutional thing, and we can take a break, madam, 10:45. So this is exactly the math. We did this math, remember? 3 into star into 4 into 5. I didn't want to show this because I wanted to do the math myself and show it to you. So next, what happens is, you get this convolved picture, and again, they will do something called as a pooling or downsampling. This is also simple common sense. There are 2 types of pooling. One is called as max pooling, another one is called as average pooling. Can you look at the picture and tell me what max pooling does, what average pooling does? Professors?
Maximum value.
Max
Maximum
pooling?
value is taken in max pooling.
Exactly. So 12, 28, 20 is the maximum. So 20 goes here. 30 is the max, 30 goes here. 112, 112. 37, 37. What is this? Average pooling.
Mean is computed in average pooling.
That's all. Fantastic. Take a mean of all the 4 and you can do it. So this is the type of pooling. So this is an overall picture. You convolve the picture into kernel and you will do a pooling, and this way you apply a convolve 3x3 kernel and a stride one with a max pool of 2x2 filter or a mask, you get this output. So this is the output that you get. This is a fully connected convolutional neural network. When you give a car, you have a convolution neural network. What is this ReLU? What is this, guys? What is this
Activation
ReLU?
function.
Exactly, beautiful. You do an activation, conReLU pool. What is this pooling? So after with whatever you did, you will do again pooling. Based on the pooled picture, again they will do conReLU pool, conReLU pool, and then finally they have a fully connected network, which will, after it goes through all this, it tells you this is a car. If I am having car percentage, truck percentage, airplane, ship, horse, what kind of activation function would I have used here? Like there is ReLU here, right? What kind of an activation function should I have used here for this output?
Softmax.
Superb, madam.
There.
Very good, madam. These people are very good. I'm really happy.
Okay.
So when you come back, we will quickly run through RNN, and then I will show you a Google Colab, and then I'll take you into the exciting world of text mining. We'll go for a break, right, madam? Break now about 10:45.
Oh, yes, sir. Yes, sir. 10:45 to 11. We'll get back 11.
So hope you guys were able to follow